Hey Global Impact students, this is Mr. Ellinger. Hope you're doing well today. This lesson is on order of operations and evaluating expressions. We have two learning targets for this lesson. First is to simplify expressions involving exponents. The second one is to use the order of operations to evaluate expressions. Some essential understanding for you in this lesson. The first one is that powers can be used to shorten the representation of repeated multiplication, such as 2 times 2 times 2 times 2 times 2. When simplifying an expression, operations must be performed in the correct order. And those are the two things that we're going to address this lesson. Alright, so the first thing that we're going to take a look at are what are called powers. They're mathematical expressions. Basically what a power has an exponent in it. Any expression that has exponents in it, those parts or those terms of the expression that have exponents in them are called powers. So here we have an example of a power, 2 to the 4th. That's how we read this, 2 to the 4th, 2 to the 4th power. Okay. The little number 4 is called the index or exponent and tells us how many times to multiply out the big number 2. The big number 2 is called the base, and this is what we multiply together however many times the exponent or the index tells us. So as you can see, 2 to the 4th basically means 2 times 2 times 2 times 2. Multiply 2 by itself 4 times. So what is the simplest form of these expressions? A lot of these problems that we're going to do, we're going to have a tendency to maybe want to use a calculator. We can use a calculator to check our answers, but one of the examples that I have here, it's going to be fairly clear to you what your answer should look like after I show you how to do the problem. We don't want calculator answers, decimal answers. We like to keep things in the form that they are in the original problem. So our first problem here, 3 to the 8th, understanding what exponent's telling us to do, 3 to the 8th power. It's telling us to take the number 3 and multiply it by itself 8 times. So basically 3 times 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 3. Now obviously this is a little bit of a lengthy problem. I'm going to get an answer of 6,561. So we say that 3 to the 8th power equals 6,561. We would say that that's simplified. And we'll talk more about what simplification means, but for now, if you see the word simplify, it just means do it, calculate it. Find out what the value of 3 to the 8th power is. All right, our second example here is a little bit different. We have a fraction here inside a set of parentheses, and that set of parentheses is to the 3rd power. Okay, so when we look at this, we need to understand that this whole parentheses is being raised to the 3rd power. So understanding what to the 3rd power means, take the base. Well, the base is 2/3. So we're going to take 2/3 and we're going to multiply 2/3 by itself 3 times. The way that we multiply fractions is to multiply the numerators together. So we're going to multiply 2 times 2 times 2. That is 8. And we're going to multiply 3 times 3 times 3, which is 27. So this power, 2/3 to the 3rd power, has a value of 8 over 27, or 8/27. Going back to my calculator discussion, we could take our calculator, do 2/3 to the 3rd power. Our calculator may give us a decimal answer. We don't want those. We don't want decimal answers. As we move further along, we'll talk about why. Decimal answers a lot of times are no good because they're not as precise as a fraction like this. Okay, so let's talk about simplifying some expressions that have multiple items in them, multiple operations in them. If you were asked to simplify this expression, how would you do it? And then a second question is there only one way? One person may look at this expression and just basically go from left to right, just as you would read a sentence on the page. So if I were to do that, 4 squared means 4 times 4. That's 16 minus 6 divided by 2 plus 7 times 2. Next, I will just do 16 minus 6, which is 10. And you can see I'm just doing one operation at a time. 10 divided by 2 is 5. So I will write 5 plus 7 times 2. Well, 5 plus 7 is 12 times 2. 12 times 2 is 24. So the person who looks at this problem and says, oh, I just calculate from left to right, will get an answer of 24. I'm going to write 24 off to the side here. Someone else may look at this problem and just say, oh, you know, I like to add, so I'll just go ahead and add first. So I will go ahead and add 2 plus 7 here. So I will have 4 squared minus 6 divided by 2 plus 7 is 9 times 2. And then they'll say, oh, well, you know, multiplication, I like multiplication too, so why don't I just go ahead and multiply? 4 squared minus 6 divided by 9 times 2 is 18. Well, this exponent looks interesting. Why don't I do that next? 4 squared, I know 4 squared means 4 times 4, so I'll just write 16 minus 6 divided by 18. 16 minus 6 is 10. I'll go ahead and do that. 10 divided by 18. Well, if I'm not going to use a calculator, 10 divided by 18, doing it the old-fashioned way, $18 doesn't go into 10, so 18 goes into 100 5 times. That's 90. Subtract, I get 10, bring down the 0, that's another 5. 5 times 18 is 90. Subtract, I get 10 again, bring down another 0, and this goes on and on and on. So I see, well, this is 0.5, 0.5 repeating. So this individual might say, well, the answer is 0.5 repeating. Clearly, those are two totally different answers. So we have a bit of a problem here. We can't just calculate things in the order that we'd like. We have to do it in a very specific manner. That leads us to our discussion of order of operations. At the top here we have a box, a key concept box, that discusses order of operations. Item number 1 says perform any operations inside grouping symbols such as parentheses and brackets. A fraction bar also acts as a grouping symbol. There are other grouping symbols. Curly braces, we'll see those from time to time. Those are grouping symbols as well. So parentheses, brackets, and curly braces are usually the 3 most common types of grouping symbols that we'll have. But again, as it mentions, the fraction bar is also a grouping symbol. And number 2, we have to simplify powers next. Okay. Number 3, we multiply and divide from left to right. And number 4, we're going to add and subtract from left to right. So we're going to do all of number 1 first. Then we'll do all of number 2, then we'll do all of number 3, and all of number 4. And those of you that have had this before, there's a mnemonic device that gives us a way to remember the order of operations. PEMDAS, P-E-M-D-A-S, is one way. Some people also remember it as please excuse my dear Aunt Sally. The P, the E, the M, the D, the A, and the S all give us a way to remember parentheses, exponents, multiplication, division, addition, and subtraction. So let's apply the correct order of operations to this problem and see what we get. Again, our answers from before were 24 and 0.5 repeating. So we look at our expression here. We don't have any grouping symbols, so we can skip number 1. We have a power here, so we're going to simplify that power. 4 squared is 16 minus 6 divided by 2 plus 7 times 2. No more powers, so let's move on to number 3. Number 3 says multiply and divide left to right. We can do these both together in one step. Here we have 6 divided by 2, that's 3. So these two are going to simplify into 3. We have a 16 here, so we're going to do 16 minus 3. These two numbers combine to this. We have an addition sign. 7 times 2, that's 14. So we'll do both of those, division and multiplication, together in one step. And then the only thing that's left is to add and subtract. Once we get down to addition and subtraction, then we can just go this minus this plus this. So 16 minus 3 is 13 plus 14. Well, that's 27. So the correct answer is 27, not 24, not 0.5 repeating. Both of those are incorrect. 27 is the answer. If we calculate in whatever order we feel like that day, we could have a room full of people getting a bunch of different answers. If we follow correct order of operations, we'll all get the same answer, and that is what has to happen. Just wanted to address a keynote about order of operations. I found a really good paragraph or two about the order of operations that discuss how they're built. So I'm just going to read through this and you can read through it with me. Operations are ordered in a logical manner based on a level of complexity. Because addition and subtraction are inverses of one another, meaning they undo each other, they occupy the same place in the hierarchy. Consider the natural numbers. Since multiplication is repeated addition, it is higher in the hierarchy. It occupies the same place as its inverse division. Because powers are repeated multiplication, they occupy the next level of the hierarchy, along with their inverses. Roots. Grouping symbols, such as parentheses, brackets, braces, are used if there is a need to interrupt the natural order. So if you know what a hierarchy means, it's kind of like, well, these are more important than these are more important than these are more important than these. It gives you an idea of how this hierarchy, this order of operations is structured. It follows a structure, a very logical structure. So while a mnemonic device such as Please Excuse My Dear Aunt Sally or PEMDAS may be used to remember the order of operations, it is important to understand the logical reasoning behind the order of operations so that we can make sense of our work and avoid misconceptions the mnemonic may cause. For instance, someone may mistakenly assume that addition comes before subtraction because it is first in the mnemonic, when in fact they are of the same order. Another good reason to know which operations come first are the limitations of technology. Not all calculators adhere to the correct order. That's right. Sometimes the calculator does things incorrectly in terms of what we really want it to calculate. And we'll address some of these more later. So just something to think about. So what is the simplest form of each of these expressions? Well, if you follow our correct order of operations, here's our fraction bar. Okay, this is called a fraction bar. It's a stacked fraction. It's what we call a stacked fraction. The fraction bar, if you remember, we said the fraction bar acts like a grouping symbol. Well, what that means is we're going to work with the numerator, strictly the numerator, and strictly the denominator separately. And then maybe at the end, once we get down to a number in the numerator and a single number in the denominator, maybe we could reduce the fraction that we get. Okay, so just looking at the numerator here, we've got the number 4 plus a power, 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3, which is 81. In our denominator, 7 minus 2 is 5. Okay, so let's simplify our numerator. 4 plus 81 is 85. 85 over 5. Well, 85 is divisible by 5 because of the 5 in the ones place of 85. So we can reduce this fraction out, and we're going to get a whole number answer. 85 divided by 5 is 17. So this expression has a value of 17. Our next word, evaluate. What does it mean to evaluate an expression? Well, if the expression is numeric, as the ones that we've been doing, evaluating it, we really don't evaluate it, we're doing what's called simplification. Evaluation comes in when we have variable quantities in our expressions, and then we are told specifically what those variables, what their values are. And then we take out the variables, substitute in the numbers assigned to those variables, do some calculations, and then we'll get an answer. Okay, so it's like an extra step of the problems that we were just doing. So we evaluate an algebraic expression by replacing each variable in the expression with its given or assigned value. And here's a tip. When you replace the variables with numbers in the expression, put parentheses around each number being substituted into the expression. This is a good habit to get into moving forward. It will save you some confusion when we start working with more complex expressions and equations. And you just have to trust me on this, okay? You might think it's a little bit unnecessary now, but if you can get into the habit of it now, it's going to pay off for you in the future. Alright, so we have two examples here. What is the value of each expression below when a equals 3 and b equals 4 in the following expression? So they're telling us a has a value of 3, b has a value of 4. So we're going to take out a and b in our expressions. We're going to replace a and b with 3 and 4. Then we'll have a numeric expression that we can then simplify. So let's take a look here at our first expression. 3b minus a squared. Okay, so we've got the 3. We're going to take out b and we're going to replace it with 4 minus a squared. Well, a is 3 squared. So that's what our expression looks like after we've substituted the value of the variables in for the variables. Okay, so our next step would be to calculate 3 times 4, which is 12. Calculate 3 squared, which is 9. 12 minus 9 is 3. So 3b minus a squared has a value of 3 when a is 3 and when b is 4. If a and b were different values, this expression would evaluate to a different answer. If you remember back to our last lesson. Second expression, 2b squared minus 7a. Let's evaluate it. So we have a 2. We're going to take out the b, replace it with 4 squared. Remember, this is 2 times quantity 4 squared minus 7 times 3. This is critical here. Remember our order of operations for this part. 2 times the quantity 4 squared. We have to square 4 first. So we've got 2 times 4 squared is 16. Sometimes there's a tendency to multiply 2 times 4 and then square it. That's incorrect. Minus 7 times 3, we could go ahead and calculate that because we don't have any powers over here or anything. So that's 21. 2 times 16 is 32 minus 21. 32 minus 21 is 11. So this expression over here has a value of 11 when a is 3 and when b is 4. If a was a different number and b was a different number, we would surely get a different value for this expression when we evaluate it.